Hey there, Internet peoples. My name is Joe Matachik, and today I'll be giving you guys a quick demo of a Raspberry or Hyperledger Fabric version 1 network running on a Raspberry Pi Docker swarm. What it's going to consist of is our curtain here. This curtain is going to basically give you guys an indication of what's going on in the network. Indication lights on when it's working, when the chain code's installed, and when our anchors at our two core peers have been established. Behind the curtain, we just have some wires to run all the lights, and then of course our Raspberry Pi stack. We have 4 cards here. As you can see, 2 of my Raspberry Pi 3s, the built-in Wi-Fi drivers just kind of gave up on me, so I've got those wired and or using an external card. But these are all Raspberry Pi 3s, and they're already connected to a Docker swarm. With all that, let's get to the next part. All right, let's start running our tests. So in order to get started, I'm going to start up my monitors. These are some Python scripts which are going to run my lights. I'm going to start these up one by one. They're doing some function tests on my lights. And all the lights are working perfectly. On my master here, I've actually got it running in the background as a Python executable. And we're going to run the stack. So we're going to use Docker Compose to do a stack deployment across our Docker swarm. And all these files and everything that I'm using is out on the Hyperledger Pi Composer repo under Clean Shooter, my GitHub tag. So this is going to basically deploy the stack and then give us a Docker PS or a list of our active running stuff so that we can tail the script. So we're going to follow along as it boots everything up. You can see that it's starting several peers, the orders, the CLI tools, and you can see that some of them are already kind of starting to queue up. And then once it's done launching everything, it'll give us our Fabric peer. We want the tool here, so we copy this guy, Docker logs, paste, and then we follow it. So by following the Docker log for the CLI tool, we're going to be able to see the byfn script execute across all of our containers, and we'll be able to see the communications from each peer as things are happening. As you can see, the byfn is starting up right now. So first things at first, we actually need to create a channel, and that channel will be used by all the peers, and that's the channel that they'll join, and that's our blockchain essentially. Each channel is its own blockchain. So now we're going to add the peers one by one. So let's get that first peer. You can see it processing up on the top right. We've got peer 0. Let's go ahead and get peer 1, aka that guy. Let's go ahead and get peer 2, or node 2, which is actually peer 0 for org 2. And then of course, let's go ahead and last but not least, get our third node, which is peer 1 and org 2. So in this particular setup, I've got 2 orgs, and each of them are going to need an anchor peer. So now that we've got all of them joined to the channel, we need to establish which peers are the anchors for those organizations. So first of all, we're going to establish one, and you can't see the communications on that one because the script that is running for peer 1 is actually on running in the background on the master node. But now it's actually, you saw all that communication back and forth was the establishment of the node and all the other peers knowing that that's the node for org 1, the anchor node. Now we're going to do the same thing for org 2. Same thing again, they all flash, we establish our anchor peer, done. So now we've got our anchors, we've got our peers, all on the same channel. Let's get some chain code installed. So the chain code is really just some simple example smart contract stuff. We're going to install that on one of our peers out in org 2 to start with. So our script is doing that. It's instantiating the chain code for that, and that's doing that out on org 2, peer 2, which is our anchor peer. So you can see it working over there on doing that. So once it's installed, it's actually not going to be used until we actually run a query against it. So we're going to run that query, and you can see that the chain code is now installed and actually running. So that Docker container that's running our smart contract is actually in existence at this point. So now that we've got it and we've queried it, we're waiting for the query to come back, and we're going to install it out on peer 0 as well. And that's in our first org. So it's setting stuff up. It's installed. Now we've got it on peer 0 and org 1, peer 0 and org 2. Now let's do some other fun stuff. Let's invoke a transaction. So you can see it working there. It's instantiating some more chain code on a different peer because it's going to go do another query out on our third node, which is our peer 0 or peer 1 for org2. So right now it's doing the installation, and it's sending the query right now. So we should see the chain code installation flip on shortly here. There it is. It's thinking. Oh, it got the queue. Come on, baby. And there it is, installed and the query completed. So, and more importantly, our BYFN executed successfully, and we've gotten to the end of our script. On our lights, you'll see that the chain code was installed on 3 out of our 4 peers because we never actually queried anything against node 1, and it didn't really have a lot to think about. So that's kind of one interesting thing about Hyperledger that you need to take into account when you're building stuff out. It can take a little bit of time for those kind of things to proliferate through your network, but they will pretty much automatically as you're using the API and the SDKs to query against your Fabric network. You'll notice that you have to have anchor peers across different organizations and all that kind of fun stuff that you need to do for Hyperledger. But most importantly, we've proven that we can successfully do this on a Raspberry Pi Docker swarm. In future tutorials, I'm hoping to kind of show what it would do on Kubernetes on a Docker or a Raspberry Kubernetes cluster and stuff like that. But the really cool thing, the real reason that I wanted to do this project was to prove out that the network could be put across different machines, and without me having to have a whole bunch of really large physical servers at my disposal. So Raspberry Pi seemed like the opportune thing to use. I want to thank everyone who's put comments on my blog for all of the feedback and thoughts and encouragement to finish out this series. If there's anything else that you guys would like to see me do, like I'm probably going to try and do a v1.1 next, and I'll probably have that be a much shorter tutorial because hopefully it won't be as intense of a process. My hope is that over time this project gets easier to do as time goes on. And easier to use so that the barrier to entry for business customers and individuals is a lot lower than it is right now. All right, thanks.